Hi, Kelly Dack here, back with you on our third day of Altium Live Connect 2022. Hey, I'm still up here in La Jolla. We've had to vacate the IPC Apex show floor, as I mentioned yesterday, and we're at the fine offices of Altium here in La Jolla. This is not a fake background behind me. This is what the skyline looks like in beautiful La Jolla, California right now at right at 10:38 Pacific Standard Time. So thanks for joining us. Thanks for being with us. I have an interesting guest this morning. We're going to chime in with a gentleman who gave a presentation, I believe yesterday, on multi-board, the topic of multi-board, and Altium's multi-board solution for collaboration between design teams so that we can create products faster and with more accuracy through collaboration. So Chris will be joining us soon, Chris Carlson. And until then, let's wrap a little bit about the show. We've got lots of Q&A, lots of opportunities to ask questions, and we hope you're taking advantage of that and maybe being a little patient. Sometimes we have a little trouble getting to the questions. There's so many coming in, but sometimes with live presentations, we have to work a few bugs out. So I appreciate that. And look who's joined us, Chris Carlson. Welcome.
Thank you. How you doing, Kelly?
Great. I like your background. Do you like ours?
I like yours better.
Oh, come on. Yeah, Chris, you and I had spent a little time getting to know each other during a little test run of this, and again, appreciate you coming on board and chatting with us. And we thought what might be a good strategy. You didn't have a chance to get to know people, our audience, as much because we got to get to business. Maybe tell us a bit about your background. We both come from probably a similar era of beginning our design careers. Tell us how yours went, and tell us some of the stepping stones that you went through to get to where you are, to a point where you have enough knowledge to pass on to our emerging engineers.
Sure. Well, after high school, I went to a community college that had an accredited 2-year electronics engineering technology program. And after that, I worked as an electronics technician for 8 years. Started out in the computer industry for 3 years, and then I worked in a hospital for 5 years. It's biomed tech, basically keeping the hospital running. And after that stint, I went back to Oregon State University and got my double E degree. And my first gig out of there was in industrial controls. Food processing industry, water handling, all that kind of stuff. And then I got into.
Did you start as an intern at a company, or did you jump right in and hit the ground running?
No, I jumped right in and hit the ground running. I actually did have an internship 2 summers when I was at Oregon State. I worked at there's a kind of a resort town in near Bend, Oregon, called Sun River.
Love Bend.
And
Okay.
yeah, well, it's a big thing for college students to get, half a dozen of you together and rent $1 million house for the summer. And,
They have like
most
12
people worked
bedroom
at the
houses there
lodge.
at that gig. Yeah.
Oh, yeah, yeah. It's a pretty interesting place.
Right.
And there was a little biomedical company there that made electronic monitoring for doing biological studies. So they actually made implantable devices that would measure body temperature, heart rate, and other physiological parameters of animals in studies. And so I worked there 2 summers and just kind of hung out and did a lot of mountain biking and stuff. So that was a
Hmm.
pretty good gig.
Yeah, but different from the controls background that you had. You moved on to
Yeah.
what would you call this type of electronics that you were dealing with? What type of
Well,
family of electronics?
well, industrial controls,
Still
basically.
industrial controls. Okay.
Well, back then, and then from there, I went to work for a company developing a motor drive, and so I got some pretty relevant power electronics background there. And then I was a principal in a startup company. We did active power factor correction devices,
My
and
goodness.
more power electronics. Only this was all grid connected. And from there, I went to work at General Atomics, and I worked on the electromagnetic aircraft launch system. It's the most capable linear motor ever fielded. It basically replaced the steam catapults in the current generation aircraft carrier. And um,
Amazing.
I, yeah,
So
not too
you
long
went
after.
from smaller things, obviously from smaller projects to larger projects. We were talking about you know that's very high velocity, high powered, possibly dangerous equipment there that you had. It must have been fun, right? It had to have been
It
fun.
was, yeah. Oh, yeah. Anything that explodes is fun. And when you your control algorithms go sideways, I mean, stuff goes off like a shotgun. Well, that went off like a cannon. So
Right.
I
Yeah. Oh
actually,
my goodness.
during that stint, we built a half scale model out at the Naval Warfare Research Center in New Jersey. I moved out there for a year and a half to be the director of the test site. And as you alluded to, everything on that test site would kill you.
Yeah, like we say that on the ranch I'm on, our cattle ranch. There's 1,000 ways to die,
Yeah. Oh,
in these things.
yeah.
These we tend to pick things more challenging, dangerous, adventurous things.
Right.
I would consider you a very right-brained person. So super.
Oh, yeah.
Well, maybe let's get into our flyover of your presentation the
Okay.
other day. Let's talk about multi-board. Let's talk
Okay.
about some of the benefits and maybe just another overview for people. What do we mean by multi-board, and how is it going to help us collaborate um, in general? Let's try that.
Um, well, a large majority of products nowadays have to have multiple boards in them. You've got, for example, a PC motherboard, and it has memory cards plugged into it. It has a graphics card plugged into it, and so on. And when considering a product development, if you look at an overall system block diagram, it kind of lends itself to carving that up into various subsystems. And then
Yes.
those can be assigned to individual contributors so that the overall project, the product comes to fruition more quickly.
Yeah, there's
But
natural breaks,
those,
but if you determine which parts of the system can be broken up into different boards, that would be a natural
exactly.
separation. And why not
Yeah,
work on
there's
them in parallel?
right. And then, there are certain expertise that might go with those different subsystems. So, your power
Great point.
electronics person can work on that part while somebody that's more apt at analog signal processing can go there. And the big thing, though, is communications. How does all this stuff come together? Um, back in my motor drive days, in fact, I've got something sitting here. You want to see it?
Absolutely. We were
Okay.
talking before, and my phrase is, a picture is worth 1,000 words. You can show us a picture, but if you've got the actual part in hand, a part in hand is worth 1,000 pictures. So do show.
All right. Well, this is a motor drive product that I had a lot to do with. This is a 20 horsepower motor drive minus the DC bus caps and heatsink. But, this is a modular design. The cover comes off and we have a control card, right? Get
Yeah,
this up here where you can see it in the camera.
yeah, yeah.
Then you've got your gate drive circuitry. That's the piece that was my expertise.
Yeah, can you
And
push in a
then,
little bit on? Let's spend some time on those boards there.
okay, okay.
Push in a little
So,
bit there,
okay.
Chris.
So this is, um,
Little
The
tilt for the glare to
powertrain,
reduce the glare, and we'll be good. Little tilt, yeah.
uh, how's that?
Backward tilt, probably backward tilt. Okay, let's move. That's good. Let's try it. Let's
Okay.
go with it. Sorry.
So anyway, the gate drive board then mounts to the powertrain. Now, basically, we have here are IGBTs and rectifier diodes. Um, there's a housekeeping power supply over here, and this is all the stuff that produces the majority of the heat. And it's mounted on a piece of insulated metal substrate that mounts on a heat sink to get the heat out, right?
Mm-hmm.
Then the gate drive board just mounts directly on top of all of this. And in manufacturing, once this is properly mounted and soldered in, you fill the whole thing up with silicone gel. I don't know if you can see it, but this actually has gooey silicone stuff in here. That's basically to keep the lightning bolts from happening.
You know, this is great that you're showing this, because we had the opportunity to stop by. If our viewers will maybe roll back to some, we've got all the traveling that we did on the show floor the other day. It's all archived,
Mhm.
and if we'll roll back, we visited a solder mass or a potting material supplier who showed us that
Okay.
very material. It's clear silicone product that you can see through, uh, and do some of your inspection if required. So yeah, I think we
Yeah.
can see what you're talking about.
Yeah. So once you start putting all of this together, everything has to properly align. There's some
Hmm.
headers down in here that the gate drive board has to interface to. And then there's a header on this card that has to mate to the gate drive board. And the communication between the different teams was paramount. Now, we didn't have a tool back in that day that could handle this. And so, spreadsheets, mechanical drawings. If one of those interfaces had to change, you had to make sure everybody knew about it. And at the end of the day, it's got all fit together. And
Well, this has
we actually
been
made little
traditional.
cardboard. Yeah,
This has been
that's
a
traditional
traditional
how it's done.
methodology, and it's still going on, right? This is still
Oh
very
yeah,
traditional. You do one board over
yeah,
here, you may send another board out, and the possibility for misconnection or miscommunication is, I think we've all experienced that at one time or another in a
yeah.
project team. Yeah. So tell us
Well,
more.
and
Tell us how it works together.
there's some simple things that you don't always think about. For example, now I cut the pins off because they were getting all bent and stuff, but
Hmm.
this is basically a header that brings the gate drive signals down from the control card.
Right.
Well, if you think about a header and a socket, those two going together, and you think about the schematic symbol for that, once you mirror these two things, pin one doesn't go to pin one. It goes to the pin on the opposite corner of the connector. So, you got to think about these things, and you've got to manage your library appropriately and,
Yeah. Hang on,
standardize that you're going to mirror the.
I'm having a real bad flashback about a project once. Yeah, I can totally relate to what you're talking about. It's wonderful. Thanks.
Yeah, we actually even, as we were trying to fit things together, we actually cut up little paper dolls of things and kind of,
Yeah,
figured out how this
yeah,
was all going to go together. So yeah, the communications is a big part of it, and that's one of the things Altium Designer brings to the table very nicely.
yeah. And the communication you just hit on, making paper dolls, uh, is that was a form of community, and still is. I can remember even just a year ago, a paper doll scenario. However, with the graphics involved, and especially in our 3D world now that we're in, it the chance for uh, miscommunication or misalignment is greatly
Misalignment, that's a
reduced.
big deal,
Yeah.
huge deal. Yeah. In
Keep
fact,
going with this subject. It's
that's
very
how we
exciting.
started doing rigid flex, right? I mean,
Hmm.
how did you know that the rigid flex was going to fold up and fit in the box? You made a paper doll, you
Yeah.
folded it up, and you said, "Yeah, I think this will work."
Or which side the FLT
That's
contacts would it
right.
mate to the connector after it did a figure eight and spun around and ended up where it was supposed to go.
Coming right back to my comment about mirroring connectors and thinking about
Yeah,
that in your ECAD libraries and getting that all right.
yeah, yeah.
Yeah.
Wonderful.
So
Let's
yeah,
keep going. Yeah,
that's well, um, and there's lots of reasons to partition a project up. One, obviously, divide it amongst the team. Divide and conquer. But then there's also um, a product is going to evolve over time. And if you have separate modules, you might only need to update and upgrade one module for that product, and everything else can remain constant. Then there's obfuscation. You've probably taken things apart where you find a little board that's potted in something that makes it impossible to see what's inside, and you can't chisel that stuff off. I've actually destroyed things trying to resolve my curiosity before. And
yeah.
it's just a way to protect
Go
your
ahead and say it.
IP.
A little reverse engineering, and I love that term. Yeah, that's a great 25-cent word. Say it again. Obfuscation.
Obfuscation. You're going to
Yeah. So
obfuscate
it explain that
what's
for us.
in there.
We're blacking out or blanking out. Maybe in other words, we'll just use a little black potting material or opaque
Yeah, you
potting
use
material. Right? Is that what you're talking
some
about?
black or opaque potting material that's very rigid that you can't just peel off. And that makes it very difficult to reverse engineer something. And it's a way to protect your intellectual property, you
Sure.
know?
Sure.
So, yeah,
Well, let's keep going on. As we are creating these multiple boards uh, in parallel. Um, Tell us some things about. I noticed in your presentation you it was very comprehensive. You added a lot about signal integrity and how we maintain signal, not just connectivity, but signal integrity issues between boards and systems.
right. Yeah. You know, it's hard enough to get your signal integrity right just across one specific PCB. Now you're interfacing multiple boards together through connectors, and you have to maintain proper impedance profiles and considering reflections and the whole thing, throughout an entire system now.
Yeah.
Um, Connectors can be a bad actor for signal integrity. Fortunately, there's been a lot of work done in that area, especially with a lot of big backplanes on servers and things like that. So the connector companies have come up with some very nice solutions if you really need, really high speed transitions between multiple boards. And they also have tools on their website. I kind of showed one in my presentation. Samtec's got this nice little tool where you choose offerings from their product line, and then you um, basically parameterize your board and give enough detail that they'll actually run an analysis and show you what your signal integrity is going to look like going through their product. But you
Sure.
don't
Sure.
always have to get into really expensive solutions like that. I mean, think of stuff like a DDR4 parallel interface that runs on an edge connector. PCIe works on an edge connector. So you kind of have to do an overall system design. Because the biggest trade you're always facing is cost versus performance, right?
Sure.
So, looking
Sure.
at some of the other interface standards that are out there, it's really important to be aware of those and know what's available. And then, once you pick a standard, design to that standard, and you've got a high probability of success. That's what the standards
Right.
are there for, you know?
Absolutely. Uh, they will set up they'll do the job of setting up our design constraints for us if we enter them, right? Wonderful.
Right.
So
The other thing you have to
tell us.
think about is
Oh,
power
go ahead.
integrity too. But well, I was just going to
Boom.
mention,
Let's talk about
typically
that.
with a
Let's not forget
module,
that.
um, when
Because
you're
just as our signals are running down the lines and we need them to arrive at the appropriate time, uh, we need power delivery. And if we neck down or forget the uh, or neck down the power in between board to board through connectors, uh, we can analyze that now. Is that true?
oh yeah,
We can,
yeah, yeah,
and within a multi-board system, can we do that? Maybe you can explain a little more
sure.
how that works.
Okay, well, for instance, Altium has, pardon me, a power distribution analysis tool. Um, it will actually analyze all of your power rails simultaneously. That's something some of the other tools don't do. And it's a
Right,
very simple
right.
tool to use. You don't have to be a physicist to set this thing up. It was intended for PCB designers to get the information they need. When you've got a multi board system, your connector becomes a source onto a board, right? So the
Okay.
tool as it is now does not support a systems approach. You will have to analyze each board, but the connector becomes the source in the
Hmm.
analysis, okay? And you have to properly parameterize that. You have to know what the ampacity limitations are on the pins or the fingers of the interface. And you
Sure.
have to know what the series effective resistance is. But once you have that information, then you just run a power distribution analysis like any other.
Yeah, and if it shows, is it does it show up as a color coded
Yeah.
map? And
You
if you
can have
see,
it color code, right?
yeah, as you see red, you might decide to pick a couple more pins for that power to pass through type of thing, and it will
Exactly.
adjust
Exactly.
dynamically.
Yeah.
I love that.
Yeah, well, what's nice about Altium's solution is it's interfaced directly into the PCB editor. So you're not
Hmm.
exporting a file to a third party tool, running an analysis, then coming back and trying to make some adjustments, rinse and repeat. You can run the analysis and you're looking at the actual board, and then you can make some adjustments. Maybe your via barrels in an area need to
Hmm.
be beefed up a little bit. Make that change, rerun the analysis. And it does color code things.
Yeah.
There's a couple interesting things that'll help you with. One is if you're routing power and you have a component that is a considerable distance away from its associated regulators, that it will show you the voltage at the supply pin. And let's say you're sitting at right at the spec minimum um, possible operating voltage. That becomes an intermittent board, and that's a really hard thing to troubleshoot after the
Hmm.
fact.
Hmm.
And it'll also show you when copper is going to become a fuse, and it'll show you where you've got some dead copper, which if it's a high speed design, you might be thinking about some of the harmonics and is this going to re-resonate. So yeah, it's a very comprehensive little tool.
Yeah, and I'll share. I've been asking software companies for this or why we don't have this capability for years and years. It seems like, we're with stack ups, we're programming in or embedding all the detail for our stack ups. We have the copper weights, and we have the amount of copper. Why couldn't the software calculate? They know the trace widths or the conductor widths. So with
Hmm.
width and thickness, they know the cross section. They should be able to calculate the cross section, and therefore, maybe I'm making it too simple, but therefore should be able to calculate the current carrying capacity of the conductors. And I have not
Yep.
seen that. I hadn't seen that on software. I'd asked for it at trade shows and couldn't really seem to get an answer, but I'm glad to see and hear that we're there.
Oh yeah, we're
Appreciate that.
there. Yeah,
Yeah.
that's
Yeah.
exactly what Altium's solution will give you.
Yeah. Right on. Well, let's go down the path of maybe we should revisit the path of the evolution of multiboard, how it came to be. How about that? How long has the product been evolving? And then maybe during the recent past few years, some of the challenges that we've had to jump through or address, and the solutions for today.
Well, multi-board, solutions have been around. I don't know exactly who came up with the first multi-board product, but I mean, even think back to things like Atari gaming systems. You had
Mm-hmm.
that cartridge that had a ROM on it with the code in it, and you plug that in. There's been a necessity of this forever. Um, where the big challenges are getting everything properly aligned, getting your mechanical housing properly aligned, and that's where the tools have really evolved over the years. We don't
Right. So
really
at
need
it
to
was
make paper dolls anymore.
Yeah, that point in time. That's what I'm asking. To be clear, as for, with the Altium product line, the evolution of the Altium product line addressing the multi-board solution. How has that come about, and the history of that,
Okay.
history of the
um,
multi-board solution relative to Altium?
right. I believe we introduced multi-board right around the time we evolved to the 64-bit platform. Okay.
Okay.
And it's actually a very well thought out solution. It takes a lot of the management out of the picture, the
Mm-hmm.
communications and all of that. You still need a person, at the top level managing all of this. But
Sure.
um, when this came about, what it allowed you to do is actually mechanically interface all of your boards together.
Mm-hmm.
You can visualize the signal paths through the headers and connectors and edge connectors and so on.
Yeah,
You
and
can check
important to
for
mention,
interference.
from a team standpoint, it's not just the designer who might be putting all this together, but working with maybe a program manager and the other stakeholder. These are the stakeholders we continually
Right.
are talking about, who are so important in these processes. We now have a way through these the multi-board strategy to to demonstrate and show uh, and define what's going on with the system, and give everybody visibility so that it can evolve
That's right.
together. Yeah.
Right.
So, how
So
about how is
go
everything
ahead.
working? How is everything working at this point? Because there were some challenges at some points. Have we addressed those challenges to today? And can we expect total success with the product today, or
Well,
is
you
there still
can.
some training
You can.
required, or networking? Does Altium offer training on these solutions? How does that work? I don't want to put you on the
We've
spot,
got
but
all
how does that
kinds.
work?
We've got all kinds of documentation, videos, how
Yeah.
tos, how to do anything in Altium. There's again documentation videos. There's a plethora of that stuff. We are
Let, let
really
me
good at
let me
that.
let me thank you. You mentioned that, and let me thank you for that, and the folks at Altium for that. Very comprehensive training videos. Amazing. So
Right.
we can learn more about how to utilize multi-board. There's lots of training videos on the Altium site. Yes.
Oh yeah, yeah.
Okay.
And the tool will actually manage your interfaces for you. And if one board designer on one of the subsystems has to do some pin swapping, that pushes up to the project. You
Yep.
can then, the product manager every so often will pull these into his system and look at those interfaces. And if something's crisscrossed, you can resolve that. It'll actually push that solution down to the adjoining PCB design. If you have any collisions between board and say components on another board, the tool allows you to move those around at the top level and then push that down to the child PCB, and so it really does manage all of this very fluidly. It's a
Yes.
really well thought out tool.
Yeah. Awesome. I don't use the term awesome very much. I think it's overused, but I think as we see these systems come into play, these design tools come into play, it really is awesome. Uh, well,
It
anything
is.
else to add? Anything else you'd like to add?
Well, we do have some improvements coming in that area
I'm
based
sure our
on
audience is excited about improvements. Let's hear about them. We we all like
based
improvements.
on popular request. One of the things that's sort of missing is the ability to, you can currently you can interface all of your boards, bring in the enclosure, and actually look at the entire product, and you have cross section views and things. What has been lacking is the ability to take something like a ribbon cable and plug it into one board and plug it into the other within that product structure.
I hear you say
So,
like dynamically, so you can move it to where it needs to go. Is that what you're explaining?
well, not just that, but managing the whole interface, which is driving the development of a wire harness tool.
Okay.
So, sometime in the future, we will actually have a wire harness project that will actually, it'll be the you've seen wire harness tools, right? I mean,
Sure.
you specify that this is an 18 gauge stranded wire. It's red. It's Belden part number XYZ. It goes from here on the connector to there, and you can have a complete mechanical representation of it, electrical representation, and all of that. That's where this is going. And then that will flow uphill into multi-board. So you've got multiple PCB projects all interfaced together. You've got a cabling project that when it's complete, then it interfaces with that product. And then you wrap the enclosure around the whole thing and check for proper fitment, look at your ventilation and so on. So yeah, Altium is a complete product design solution, and this is one of the things that's missing, and we're addressing it.
Yeah. Very good. And it, we're showing connection. The theme of the summit here is to connect, and
That's
it's been
right.
wonderful to connect with you, Chris. We haven't met
Well, I
before,
appreciate
and
that.
I'm just very pleased to hear that things are evolving and you're working behind the scenes and helping out to evolve the product and use the product and help our emerging engineers to learn more. So thank you very
That's
much.
right. No,
For
you're welcome.
now, yeah, absolutely. I've got a note here. I'm not very transparent. We don't have a teleprompter, but we have a little white sheet that I call my teleprompter, and our
Okay.
cameraman Michael will hold that up, and it says, "I'll just read it. Hey, Chris, that's you. When you disconnect, use the red phone button in the bottom left." So there's a tip for you right
Oh,
there.
there's a red phone button somewhere, huh?
Okay, but don't get disconnect
Okay,
yet.
well, tell
Let's
Michael
still
I'll
have
find it.
fun. He says he'll find it. He'll find it. Yeah, it's just been fun, and like I say, I have had such fun this whole week. Talking to people I haven't met before, but I've heard about and I've heard who are solving the problems, and now you're one of them. I had a goal at the show. I wrote a bunch of goals, and one of them was to connect with 20 new people and make new friends, and now you're one of them. Thanks very much.
All right. Are you meeting
Okay.
your goal? 20?
Well, if you'll be my friend.
Okay.
All right, you're number 19. I'm
You owe me
almost there.
lunch sometime,
uh, Friends ask friends for
friend.
lunch. I guess so. Very good. Been a
All right.
pleasure. Thank you very
It
much.
has been a pleasure.
Yeah, with me has been Chris Carlson. Yeah, I don't know if I asked your title over here at Altium.
Oh, it
Clue us in,
changes.
friend.
Technical sales engineer, field application engineer, it evolves back and forth all the time.
Okay, now that we're
I'm
friends,
on
I'll
the
write that
technical
down.
side. Yeah.
Very good. Well, with me has been Chris Carlson, a technical guy for Altium, and doing a great job out there with multibore. Thanks very much. I've been Kelly
You're very
Dack. I
welcome.
still am, I hope. Kelly Dack for Altium Live Connect 2022, and we hope to see you back very soon. Until now, we'll keep going.
All
How
right.
about our?
It's been a pleasure.
Okay, very good. Thanks very much.
All right.
Oh, hey, I also need to clue our audience in that at 12 p.m. We've got, in fact, it's going to be happening in about 45 minutes, 12 p.m. Pacific Standard Time. We've got a presentation with Ted Poella, sorry, Altium about Altium Made. Or Altimade and Nexar. So we're going to be learning about this whole concept of connecting the industry together for those not only using Altium tools, but the rest of the industry, where our designs go when they're launched and have to go to production. So again, live TV here, live broadcast, and thanks for rolling with us. I'm Kelly Dack for Altium Live 2022 Connect. Thanks for being with us. See you soon.
Well, gotta act fast. Sign up for the broadcast of the Altium Live 3.